Okay, welcome everyone. I'm Clark Nicholson from the remote desktop team at Microsoft. I'd like to thank you all for coming to the session this afternoon. We're going to be talking about remote desktop services and deploying remote desktop services in Azure partner-hosted and private cloud computing environments. But before I get started, I just wanted to get a sense about the experience levels of the audience. How many people are very familiar with remote desktop services, or what we used to call terminal server? Okay, looks like probably the majority here, at least 80%. How about Azure VMs? Have you deployed Azure VMs, VNets, and those sorts of things? Okay, looks like maybe about half. All right, well that helps me. I'll do a very quick overview of RDS for those of you, the few that I think are here that didn't raise your hand on that, and I'll spend a little more time on some of the background on Azure and how it applies here. We're going to talk first, though, about cloud computing, because I want to make sure we have a good definition of that, because it's a term that's used a lot in the media, and so therefore there's many different definitions. As I said, we'll do a quick overview of RDS, and then we're going to start drilling down into the details of how we deploy RDS first in Azure, and then we'll talk about how that extends to our on-premises clouds. And then finally, we'll talk a bit about some scale guidance. People, of course, always want to know how many users can I get in a desktop hosting environment. So cloud computing, I think of it as really an abstraction layer. And it's essentially taking the entire data center, all of the resources there, the compute, storage, and networking, abstracting it out, and then we're given an interface, or interfaces. Usually there's some sort of a graphical interface and then several programming interfaces. The benefits of this, if we always talk to this API or these GUIs, is that the underlying fabric can change and doesn't hopefully impact us too much. Theoretically, it will reduce costs over the long run, because we're going to share that hardware environment, and when one tenant in the environment is using it heavily, odds are that somebody else isn't. And so the utilization of that hardware is going to be higher, and therefore the costs will go down over time. And of course, it also simplifies things, especially in Microsoft's model, where we have this convergence of cloud on-premises clouds and our Azure cloud. Over the long run, you should be able to write one set of scripts, develop one template, etc., and it should run in either place. Now, of course, whenever you build an abstraction layer, you've got to think about certain design considerations, security, performance, and so forth, and we're going to talk about that more later in the session. So Microsoft provides several different cloud computing solutions. Of course, there's Microsoft Azure, and that abstracts the Azure data centers, which is a wonderful thing, because these people build these data centers for us. They're like little elves in the sky, and we get to use it. It's wonderful. In fact, I think as I'm doing my demos later, think about all the hardware I would have had to buy and set up to get these demos running. And then I'll tell you, it was incredibly simple using Azure, because somebody did 80% of the work for me, and all I had to do was either click a few things in a GUI or run a few PowerShell scripts. Of course, with Azure, we provide both infrastructure and platform services. And as I said, the GUI we have there, the interfaces, are our management portal, our REST, and our PowerShell APIs. Now, we also have what we call the Microsoft Cloud Platform. We used to refer to this as Cloud OS in our previous marketing. But this essentially abstracts your data centers. Okay? And it's essentially combinations of our products, primarily Windows Server, System Center 2012 R2, and our Windows Azure Pack. And of course, in this case, the APIs we talk to are the various PowerShell APIs and the Windows Azure Pack GUI, or the VMM console. Now, of course, whoops, I skipped. Of course, we also have our Microsoft Cloud Platform System, CPS, powered by Dell. That's where we've basically taken our Microsoft Cloud Platform software, worked with Dell, and they've built an integrated turnkey solution, hardware and software ready to roll in a rack, basically. Okay? All right, now let's move on to the RDS overview. RDS, sort of moving from left to right, we originally developed a session-based desktops. We used to call them terminal servers. We added our remote app capabilities. Then we added VDI, where we could spin up client operating system VMs and connect people to that. Now we're moving on and talking about RDS deployed in IaaS, either in Azure or your partner-hosted clouds. And then most recently, we've built a service, a finished PaaS service that we call Azure Remote App, where we've simplified this all down to where you just upload an image, and then we essentially build the infrastructure around it for you. Now today, we're going to be talking about that red box there, RDS on IaaS. That's the focus of this conversation today. All right? Now, one thing I want to point out is you'll hear me talking lots about server desktops, okay, and running apps off a server and so forth. And those of you who are not familiar with our licensing, I should probably explain that it is not allowed. We don't have any licensing to put client operating system in a VM in a shared hardware environment like Azure or one of these cloud computing environments. So what our hosting partners do, and what we're documenting here and talking about, is deploying servers, and typically then we skin them, that's called, to make them look and behave like client. Okay? All right, so remote desktop services that comes in Windows Server. There's 5 basic components. There's the session host. That's where the work's actually being done. Users, that's where they log in. That's where their desktops are running. That's where their apps are running. We have a connection broker component that distributes connections across multiple session hosts. So you can build farms of session hosts and connect users to those through load balancing. We have an RD Web Access component that allows you to have a portal that users can connect to and log in from a browser, and then download we publish an RDP file that they can then connect to whatever resources, whether it be desktops or apps, in the deployment. We have a gateway component, and this allows a secure connection from a public internet, for example, to be able to access that deployment, whether it be in the Azure cloud or a partner-hosted cloud. And then finally, we have our license server, which helps administrators track usage of the system. All right, now we also have our Microsoft remote desktop apps. We support multiple platforms: Windows Phone, iPads and iPhones, Mac, Android, and through these clients that you can download from the various stores, you can then access both full desktops or remote apps on any of these devices. And then we deliver a great Windows experience, and we keep the data secure, right? Because now the data is still living up in the cloud. All we're doing is remoting the GUI, basically, and the keystrokes back. So it's a very secure way for users to be mobile and access corporate data, and it's so that it never comes down actually onto the device, and so there's no worry about losing that device. All right, so we're going to drill in now a little deeper on deploying RDS in computing. First, I want to talk about some architectural concepts and goals that we had in coming up with our guidance here. So our design goal, first and foremost, we have to make this secure because that's the biggest concern. Every time we do a poll, or anyone does a poll about moving into the cloud, it's all about security, right? So we absolutely have to get this one right. So it had to be secure. We have to have strong tenant-to-tenant isolation and strong tenant-to-provider isolation. Of course, it's got to be performant. Our users expect it to run just like as if they were launching an app or running a local desktop. And so, in particular, our connect times have to be low, and our latencies when running apps and desktop. From the research that we've done, most of the growth in hosted desktops and hosted apps is in sort of small to medium companies right now. So our design goal was to span 5,000 to 5,000 users per tenant. We wanted to make it flexible. We wanted to support both desktops and remote apps. And we wanted to offer the ability to have administrative access to a personal desktop, right? Because a lot of companies will have one or two people who really want to just have their own, have administrative access and be able to install whatever apps they want. And of course, it's got to be reliable. It's got to be there when you need it. Okay, so architectural concepts. We're going to first talk about what we call a basic RDS deployment. Okay, and the nice thing about the way that RDS is implemented is you can kind of build it up in layers. You can get a very simple basic deployment running. It's not highly available, but it works. It functions, and then you can start layering on a higher availability for the different services, and doing other enhancements on that thing you built. You don't have to start over again to get that. So we call that extended deployment when you start building those layers on top. You'll do things like create a remote app collection, make it highly available. You'll implement personal desktops and so forth. Now, we'll also talk about different types of environments. Okay, so there's the Azure virtual machines that are running up in the Azure data centers. There's the on-premises environments, and then there are, of course, hybrid environments where we connect the two together so that a deployment in Azure could potentially access resources back on-prem. Okay, so we're going to talk about some Azure concepts here for those of you who didn't raise your hand earlier when I asked about, are you familiar with Azure? So one of the basic concepts we have up in Azure that we're going to utilize heavily in our deployment guidance is virtual networks. So you can create a virtual network with a private address space and land your VMs on that VNet, and none of the other tenants running in Azure can get access to that, right? But your virtual machines then can all talk to each other. And then we also have this concept in Azure of a cloud service. And essentially that's a way for us to take these private addresses that I may have dropped onto that virtual network, the VMs, and actually provide a public connection to that. And that's done through the cloud service. So it's essentially a way for Azure to create a DNS name and a routable public IP address so that users can access these VMs if they need to, right? All right, so this is a basic block diagram then of what a basic deployment would look like in Azure. So the components that are in blue, those are what come with Azure. So the nice people at Azure, at the bottom you'll see they've built compute, storage, and networking infrastructure for us to use. And at the top, they've got their management portal, and they have their what I call perimeter services, things like a load balancer, VPN connectivity, and so forth. The box in the middle with the green boxes, that is what we're going to deploy for our tenants. And our users will log into this. So you can see in the lighter green boxes, those are the 5 RDS components we talked about earlier. RD session host, connection broker, web, gateway, and license server. The 2 darker green boxes represent 2 role services that are required by RDS to deploy. So Active Directory, and this is not Azure Active Directory, this is Active Directory domain services that's in server. And of course, you've got to have an SMB file share if you want to use what we call our user profile disks. Okay, and you can see that those components are all going to be running on this tenant's VNet. Now, in order for us to scale this solution down, and by the way, when we talk to our hosting partners, that's actually one of the biggest problems they have is how do I scale deployments down, because they have so many customers. There are small businesses that have 15, 20 users. And so what we recommend is combining role services, because your costs are going to be driven primarily by VM costs. So you want to minimize the number of VMs in your deployment if you can. So the minimum we recommend is 3. So we'll have 1 VM that houses both the gateway and the RD web components. We'll have another VM then that houses Active Directory, the file server, the licensing server, and the broker, and a third VM that has our session host server. Now, of course, if you're going to deploy something for a larger user base than, say, 15 users, then you would want to start breaking these components out into separate VMs. Okay? Now, a user, the way they would come in and access this, once this is deployed, the admin would simply give a URL to the end users and tell them where to go to get to the RD web from the internet. They'd connect up to the RD web component. That would challenge them for username and password. That would get authenticated against the AD that's in that deployment. And at that point, they would be shown resources that this administrator has published for them, either desktops or apps. When they click on one of those resources in the web page, we're going to publish an RDP file that's going to come down to their computer and connect them up through the gateway to the broker, which will then route them to the appropriate RDSH server. In this case, for my basic deployment, I have one, so it's always going to go to this guy. And if a second user logged in, obviously they'd land on this same VM and run a second session. And then if one of those users launches IE, let's say, Internet Explorer, a browser, they're going to come back out to the internet through Azure's perimeter services. Okay? Now, for larger customers, tenants, they may have some on-prem resources, and they want to connect up these desktops in the cloud back to maybe a SharePoint server or something back on-prem. So to do that, you can create a VPN connection or express route connection back to the on-premises network, which effectively connects those two together. And now, for example, I could make the AD server that's up in the Azure deployment could simply be a replica of the domain controller on premises, right? Now, as I said earlier, it turns out it's fairly simple to build this thing, okay? You're going to go create the tenant's networking environment to start with. You're going to create the VNet and the cloud service. You're going to create the VMs. In this case, in my example, I have 3. You're going to deploy Active Directory, DNS, and file share on one of those. You're then going to join those VMs into that domain, the other 2, and run the our RDS deployment wizard. Add a licensing server, a gateway, and create a collection, and then do what I call secure the deployment. So by default, you're going to end up with a bunch of VMs up there that all actually are connected to the public internet through the cloud services endpoints. And you want to get rid of all of those endpoints except for the ones that go to the gateway VM. Because that's the secure way for all of the users to get into this deployment. And it reduces what we call the attack surface then of your deployment, so that there's really only one VM now that actually is visible from the public internet. All right, so we're going to do our first demo. I've got a build of this up in Azure right now. And first of all, before we go to the actual thing, I want to show you also the documentation that we have up available for you. This is an MSDN. It's available today. There's an architectural guide that's kind of a high-level block diagram, sort of walks you through what the basic idea here is. And then we actually have a step-by-step deployment guide that will walk you through how to build this deployment I'm about to show you, which is the basic deployment. And this, I've logged into my subscription in Azure, and I'm looking at my virtual machines, and you can see that I've got these 3 virtual machines. So this first one, 81, that has the combination of Active Directory, the broker, and so forth in it. RDSH D1 is my RDSH server, and the Web Gateway 1 has my web and gateway roles in it. If I go down and take a look at my networks, I've got a VNet that I had created, and all those VMs live on that. And if I take a look at my cloud services, I've also got a cloud service. So that's going to be my public name. The DNS name is going to be Contoso 3-CS1, And then what Azure does is tack .cloudapp.net onto that. And that'll give you access into the gateway. So let's go do that. Let's see what this is going to look like from an end customer point of view. So you can see up here, I've logged into, I've connected, to the Contoso 3-cs1.cloudapp.net/rdweb. And I get our login page. So this login page is being served out of Azure. When I sign in, I get this resource. Now this is a basic deployment, so the only thing that's in it is this one desktop collection that I've created, right? So now I'm going to click on that, and that is going to download an RDP file to my machine, which is going to have the information in it that says, okay, connect to this broker, or this gateway, connect to that broker, and route me to this collection. And that's exactly what's happened. So now I'm on a desktop running out of Azure, and I can launch, of course, different applications and so forth. Okay, I'm going to disconnect from that, sign out, and just so I... All right, so let's keep going now. That was the basic deployment. Now you probably noticed that the desktop you saw there looked a whole heck of a lot like a server desktop, which is probably not what you want to give to your users in a small business, because they're probably not familiar with Server Manager and PowerShell. And so typically the first thing you're going to want to do is start extending this basic deployment by creating a custom RDSH image, right? Skinning it, making it look like client, installing the apps that you want, and so forth. Okay, you may want to add a remote app collection. Not required, but often nice to have. High availability and scale out. Okay, so you're going to want to add at least a second instance of every single role service, so that if one of them goes down, the service keeps running, right? And then lastly, you're going to want to keep your costs under control. And as I said earlier, your VM costs are going to dominate. And so you want to shut your VMs down when the system is not being, or the service is not being used, right? And so we've published a script that will automatically do that for you. And we'll go into detail later on how that works. Okay, so we're also going to introduce some new Azure concepts here that we're going to utilize for this extended deployment. Okay, we talked about virtual networking and cloud services. Now we're going to talk about what's called a load balance set. So within your cloud service, you can have two VMs essentially connected to the same endpoint. That's what we're going to do with our RD Web and Gateway VMs. We're going to have two of them, and they're going to connect to the same endpoints. But we have to tell Azure about that, and we do it through a load balance set. Okay? And then Azure's then going to load balance across those two VMs for us as users log in. We're also going to utilize a concept called the availability set. So when I create two VMs with the same role, like let's say one gateway and another gateway, I have to tell Azure that they're in an availability set. So then Azure says, oh, I'm never going to shut both of those VMs down at the same time. If I have to do a servicing event on one of my hosts, I'm going to make sure they're on different hosts, for example, and so forth, so that I can keep at least one of them always running. And then lastly, the remote desktop gateway in 2012 R2 requires two HTTP connections from the client to the gateway. And so what you have to do to make that work in Azure with Azure's load balancer is you have to set something called the distribution mode to source IP affinity. And essentially that's telling Azure, hey, when a client comes and connects, and then that same client comes and connects again, make sure they always go to the same VM, right? That's what source IP affinity says to Azure. All right, so we're going to drill into this now in more detail. First, let's look at the block diagram here. So this was the basic that we talked about earlier. And now we're going to add some more VMs to make this an extended deployment with everything that's in there. Okay, so we're going to add, in the lower right, you'll see I've added another collection for my remote app. I've added multiple VMs for everything, for every role service. And I've also thrown in a SQL cluster in here, because to build a RD connection broker in high availability, it needs an external SQL database. And then you'll see that the two VMs that run our RD Gateway role service, they have two, each of them has an endpoint, and I have to put them in a load balance set, right? And the availability sets are going to be every pair of role services, right? So my RD Web Gateway VMs have to be in one, my SQL VMs have to be in one, and so forth. And I'm going to end up with 5 total in this deployment. And then finally, I'm going to set my source IP affinity in Azure Load Balancer and say, hey, you gotta always connect to the same VM when the same client is connecting into this deployment. Okay? And today, the source IP affinity is not available through the GUI. So you have to do it through PowerShell. And this is an example of the PowerShell I ran to set this on the deployment that I'm about to show you. Okay, so I tell it the cloud service name and the load balance set. Okay, I tell it the local port. In my case, it's 443. That's where my HTTP connections are coming in. And you can see at the bottom that I've set the load balancer distribution to source IP. And that's all I need to do. And now Azure will take care of this for me, and this will work just fine. Okay, last thing as far as extended deployment. We talked earlier about spinning up and down VMs to try to lower our costs. I want to go into a little more detail on that, just so you get an idea of what we've published and what's available to you. You can use this as a starting point. I know a lot of people have contacted me and they've downloaded it and used it as a starting point and started enhancing it. That's exactly what we meant for it. It works as is. You can download it and just start running it, got documentation and so forth, but we intended for folks to use it as a starting point and customize it. So as I said earlier, VM costs are going to dominate. And so you want to make sure that you shut down and deallocate your VMs aggressively, shall we say. Because when they're shut down and deallocated, you're not being charged. Okay, so that your deployment can be sitting up there with 100 VMs in it, and if 5 of them are the only ones that are running, that's all you're being charged for. Right? And then as you need more VMs, you spin them up, right? So what this algorithm, so that's one effective way is to reduce your costs, is to get those things shut down, right? And depending on how big your deployment is, you might use different techniques. So if you have a fairly large deployment, let's say 50 to 5,000 users, primarily you're going to be concerned with those RDSH servers, right? Because you're averaging those infrastructure servers, the gateway and the broker, for example, across so many users that it's not going to be significant. It's those RDSH servers that you're concerned about. And so you want to spin those guys down during the off hours. If you've got sort of a medium-sized deployment where you got, say, 15 to 50 users, that's where you want to start combining role services into a single VM. You want to not only shut down your RDSH VMs, but you probably also want to start shutting down maybe your redundant HA VMs during the off hours, right? And then if you've got a very small deployment, let's say 5 to 15 users, that's where you're going to have to actually start shutting the whole service down in the off hours when people aren't on it. Okay, so let's go into how this dynamic scaling script works, a little next level of detail. So it's essentially a PowerShell script. It's up on Script Center. I have a link in the deck here, and we're going to look at it in a minute. You run it. Essentially, it's designed to be run periodically on your connection broker server as a scheduled task. So maybe you run it every 20 minutes or something, right? What it does when it runs is it loads in an XML file that you get to edit, that we've provided a template for you. And in that XML file, you get to define your start of day and your end of day and things like that. VM min is like the minimum number of RDSH servers you want running during the off hours. If you set it to 0, it's going to go turn them all off. Set it to 1, it's going to leave 1 running, and so forth. And then this thing we call the threshold, that's for the next morning when people start logging back in. As soon as users cross over a certain threshold, which we define in terms of users per core, per virtual CPU, then you're going to want to start, that you're telling the script to start spinning RDSH VMs back up, starting them back up. So at the end of the day, what the script will do, once it discovers it's after hours, is it's going to set all the VMs to what we call drain mode, the RDSH VMs. So that means they're not going to let any new connections in. It's going to notify the users that are logged into the VMs that it wants to shut down and say, you've got so many minutes, which you get to define, and then I'm going to log you off, so it's better save your work. And then it'll start shutting those RDSH VMs down once there's 0 connections on them. When we come around to the start of the day, and the script finds that it's now in the start of the day, it's going to go set all those VMs back to what we, fill mode in this case. So they're going to allow new connections, and then it's going to start them up as that threshold is passed. As users start coming in the morning and logging in, it will start spinning those VMs back up. Okay, so we're now going to take a look at an extended deployment that we've built up in Azure. And I talked about this documentation earlier. So these first two are are for just creating the basic deployment. We got the reference architecture guide, the deployment guide, and now we've got a number of other step-by-steps that tell you how to create a web gateway farm, how to create a desktop session host farm and customize your session host, and how to create a remote app collection and so forth, right? And we also, I'm going to show you, this is the scaling script. So the scaling script, you get the script, you get an example of the XML file, and you get a document, basically, that explains how it works and how to deploy it as a scheduled task. Okay, so now I'm over in my extended deployment in Azure, and you can see now that I've got pretty much 2 of everything, right? I've got 2 of the AD connection broker VMs, now I've got 2 different collections here, so I'll have a total of 4 RDSH servers. One's for the remote app 2 are for the remote app collection, and 2 are for the desktop collection. And then finally I've got the 2 web and gateway. Now in this case, I've only got a single SQL server. In a real production system, you'd want to set that up as a cluster as well. And then let's go just see a couple of these things that I talked about earlier. If you look at my endpoints for my gateway, you can see that this gateway server, these endpoints are in these load balance set. And if you look at the other guy, they're in the same load balance set, right? And that's what's telling Azure that those 2 go together and that it should be balancing load across them. And then the source IP is what tells it, oh, but by the way, if the same client comes in a second time, always connect them to the one you connected them to before. Okay? All right, so now let's take a look at what the end user is going to see. So again, I've connected up to this cloud service. It's a different one. It's called contoso4-cs1.cloudapp.net rdweb. Looks pretty similar. The domain name changed to Contoso4 in this case. I log in, and now, because it's an extended deployment, I've got more resources I've published. And you can see that I've installed Office on these RDSH servers, and I've published some of those as remote apps. And then I've also got a desktop collection. So if I'm to launch a calculator, let's say, from one of my remote apps, and then I'll connect up to my desktop as well, we'll take a look at what these look like. And again, when I clicked on those, both of them are downloading published RDP files that are then executing on my local machine, but they're connecting up through the gateway to the RDSH servers appropriately. So this calculator window is actually coming from Azure, right? It looks and feels exactly like a local app, but it's actually running out of Azure. And then if I go back and open up this desktop that I had earlier, so I had left a session running. I had a Paint app that I'd created, and you can see that I've got Office apps now also in this deployment. And you'll see that this desktop looks a whole heck of a lot more like what your users are going to be familiar with. I've gotten rid of the Server Manager and the PowerShell and all that stuff, and I've put the usual things like File Explorer and Internet Explorer and so forth in the taskbar and on the start pages. All right, so I'm going to close out of both of those, and I am going to take us back to the session presentation. Okay, we're going to move on and talk about the future now. So everything I've shown you is real stuff. You can do it today using Server 2012 R2 in Azure. We got, as I said, we got all the documentation and so forth that can walk you through it. So in Server 2016, we're introducing a new concept of what we call sort of personal session desktops. So this is where you build a traditional RDSH collection, but you're able to assign users to each RDSH server, so that when a given user logs in, they're going to go to the same VM every time, and they can be given admin access to that VM and install apps and so forth. So it's essentially a VDI solution, all based on server, okay? And it can run in Azure, as you'll see in a moment. Okay, so some other features that couple with this, we have this session-based, server-based personal desktops that I talked about. We're also supporting our virtual GPU technology with a server guest. So now if you're building on-prem and you own the premises equipment, the fabric, you can install graphics cards into your host servers, build personal desktops, and actually run accelerated graphics programs on them. So this expands the numbers of apps we can host and the types of customers we can address, those engineering firms and so forth. The other thing we're doing with our vGPU in 2016, if you went to one of our earlier sessions, is we're now supporting OpenGL. So before previous versions, we only supported DX11. Now we support both. So it pretty much opens up to all apps that are out there, CAD apps, games, etc. And then the last feature that really is interesting to us as folks who care about desktop hosting is we have an RD Gateway WebSocket connection we've introduced. So this way we can get all the performance we were getting out of those two HTTP connections, but with a single connection. So this simplifies our world not only in Azure, but anywhere, because the infrastructure requirements to handle those two HTTP connections turned out to be problematic for some of our customers. So now you won't have to worry about that. In fact, we won't have to set that load balancer source IP affinity in Azure any longer with 2016. Okay, so if you have the Ignite build, or you get your hands on it, this feature has been implemented, these personal RDSH-based desktops. But they're not in the GUI. They're only available through a PowerShell. So what we've done here, if you're familiar with our RD PowerShell, we've taken one of our current commandlets called new RD session collection, and we've added 3 new parameters to that commandlet. Personal unmanaged says it's one of these kinds of collections where I'm going to assign users to specific RDSH servers. Grant administrative privileges, which basically says when I do assign one, put them in the local administrators group. And finally, auto-assign user. And that way, you don't actually have to go through and manually assign. You could create a collection with, let's say, 10 RDSH servers, send out the URL to your 10 users, and as they log in, it'll just happen automatically. They'll be assigned to a VM, and off they go. Now, we've also introduced new commandlets. Okay, so we've got set, get, and remove of that RD personal session desktop assignment. So I can do it manually with the set. I can get to see who is assigned, and I can remove if somebody left the company and I want to, start over again with that VM. And then, of course, we support the import and export. Now, if you're familiar again with our RD commandlets, and in particular with our VDI, you'll notice that these look almost identical to our VDI, and that was intentional. We wanted to be very consistent with what we did. So everywhere you see a personal session desktop, there's an equivalent that says personal virtual desktop. There's an equivalent commandlet. And so this is now a whole new way, essentially, of creating a VDI deployment using server-based desktops and in a cloud computing environment. So our VDI path that uses what we call RDVH doesn't work in a cloud computing environment because it assumes that it can do things to the host server, like install software on it, right? That's not going to work in Azure. They're not going to let me install software on their Hyper-V hosts. I guarantee it. So this path is really being developed now for this new cloud computing environment and trying to give the same functionality that we have in our VDI path. So just as an example, I ran through this and created one. We're going to take a look at this in a minute. Some of these names have actually changed, but you get the idea. I created a collection. I set it up as personal unmanaged. I granted administrative privileges, and I set it up to auto-assign. And I put 2 RDSH servers in it that I created. And these are those new parameters. Now, one caveat. If you're going to try this in the Ignite build, you don't use personal unmanaged. You'll have to use personal session collection. This will be fixed in a future version. So sorry about that. Probably the first refresh after Ignite will have the personal unmanaged. Okay, and then I set an assignment for U1 to this RDSH1 server, and then I left the other one to just get auto-assigned, and you'll see that in a minute. If I run get personal desktop session assignment, it looks something like this. It'll say there's the collection name, there's the server, and there's a user. And if there were more servers in it, they'd just be in this list, right? And it'd tell me which server is assigned to which user. Okay? Okay, so now we're going to take a look at a deployment that I've built in Azure. Using the Ignite threshold build, where I've built one of these personal session desktop deployments, collections. Okay. So if I go into my virtual machines, ignore the ones that say Contoso 5, that was a previous deployment. The ones that say WSTH74, that's basically the build number. Those are the ones I'm talking about here. So you'll see that I've got a connection broker. I've got, in this case, 3 of these personal session host servers, PSH 1, 2, and 3. And I've got a session host, just a traditional session host. And I've also got my web and gateway VM. Okay? And if I were to go in and take a look, in this case, I've actually remoted into the connection broker. And I can show you this is the PowerShell that I ran as I just walked you through this. So I created some variables for the names of my session hosts, some variables for the users in my domain. And then I added those RD servers into my deployment. You got to add them first and say, hey, these are going to be session hosts. Then I created the new collection. And you can see that I set it up as a personal session collection. In the future, that's the one that's going to be personal unmanaged. And then grant administrative privileges and auto-assign user. Then I manually assigned one of the users to one of the session hosts, and then I just did a quick query on what was going on there. So now let's take a look at what that looks like from a user experience point of view. So now I'm going to be the end user, and I'm going to go to a new URL. This is a different cloud service. It's called Contoso 5-CS2, and I'm going to log in as this U1. So remember, he was assigned a user desktop by me manually, and now when I look at my published resources here, I'm going to see the traditional pooled desktop, which I built when I built the basic deployment, and then I created another collection that was these personal desktops. Okay, when I connect up, Broker is now going to send me to my VM, right? And every time I log in, I'm going to end up on that same VM. Okay, and in this case, it's going to be the Ignite build of Windows Server 2016, and I've installed the desktop experience pack, and I've done a little bit of skinning. Now, in our desktop experience pack, it's worth mentioning that we're doing a lot of work on that in Server 2016, and you'll see here I didn't have to do a lot of skinning to make this look pretty much like Win 10. And so that's going to continue to evolve as you see releases come out. Our goal is eventually to get it to look pretty much exactly like Windows 10 client. Now you'll see over here when I opened up computer management that when I looked at groups here, I opened the administrators group, and you see that Contoso 5 U1 has now been put in that local administrators group. So Broker did that for us when I assigned this user. And you can see that when I did a host name here, that I got onto my VM, and this was, a site that I had open previously, right? Now I could go in here and start installing software on this guy. I could put Adobe Flash Player or whatever I want. No problems, because I'm the administrator. If I log out and log back in, I get back to the same VM. Okay, let's disconnect, and we are going to go back to our demo, or our presentation. Now, our friends from Unidesk, oh, yes, please. Of course. Yes, the question was, can I apply group policy restrictions to those personal desktops? Yeah, they're going to behave just like any other Windows desktop, basically, right? And you've got AD in that deployment, so you can apply group policy to them. So our friends at Unidesk announced this week that they have releasing their product for their layering technology for RDSH in Azure. It's kind of a nice dovetail off of what I just talked about, since we're doing a lot of stuff with RDSH in Azure here. Now the layering technology from Unidesk will be available as well. So I'm going to go here, and I'm going to play a video that Ron Oglesby, solution architect at Unidesk, put together for us to show how this technology is going to work in Azure.
Hi, Ron Oglesby, Chief Solution Architect for Unidesk. This week, Unidesk is announcing a new version of our product to bring our layering technology to RDSH servers running on Azure. The environment we're looking at here is my Azure demo environment. All of our management components, such as our management appliance and our cache points that handle layer replication, along with all the session hosts, are all hosted in Azure. And Unidesk's layering technology allows you to simplify the management of these RDSH servers by truly separating the management of the OS from the management of the applications, getting rid of the concept of gigantic images with applications installed in them. And while these application layers are separate from the OS, when applied to an RDSH server, the apps look, act, feel, and behave just as if they were installed in an image. Now let's take a look at the Unidesk Management Console. Unidesk manages the session host servers and VDI desktops using basically two types of layers that the admin deals with. Application layers, which you can see here, and of course operating system layers. These two different types of layers are read-only and are managed once by IT. They can then be applied to session hosts and collections to update those. Let's take a look at our session hosts. Under our session host tab, we have two sub-tabs, one for collections and one for the session hosts themselves. Now this is a relatively small demo environment, so I only have about 6 session hosts and 2 collections, but you can picture an environment with 5, 10, 20, 50 different collections or configurations of session hosts and potentially hundreds or even thousands of session host VMs. Of course, these collections map directly to RDS collections that you would see in the RDS manager. And of course, the session hosts are what are used to create the RDS collections. These are all members of a collection. So in my example, we have the marketing session host from a marketing collection and the sales session host. What makes this special is the management via layers. The applications themselves are stored in their own virtual disk. When applied to a session host, they look, act, and feel as if they're installed in the image, but they're not. This allows you to have a single copy of any layer, an operating system layer or any application layer. Even if you have 5, 10, 20 different collections or configurations, you would only have one copy of 2012 R2 to patch, update, manage, make changes to. Even if you had 10, 20, 30 different collections, half of which, let's say, use Office 2013, half use an older version of Office, when Office is updated, you don't have to update every image. You update Microsoft Office one time and in one location, and then roll it out maybe to one server, maybe to one collection, and then roll it out to the rest of the environment. Unidesk layering essentially virtualizes the file system and the registry. What this means is each application and even the OS is stored in its own virtual hard drive. That virtual disk contains just the file system objects and registry entries that make up that layer. These can then simply be attached to the session host virtual machine, and at power on, the registry and file system are blended, and the app looks, acts, and feels like it was installed locally. On the session host side, you can edit individual servers or groups of servers all at one time by simply selecting Edit Session Hosts, which will allow you to modify pretty much anything about the server, but specifically will allow you to add or remove application layers and pick when those changes occur. If you're interested in hearing more about our layering technology and our solutions for Azure and on-prem environments, we hope you'd swing by the Unidesk booth down in the Expo Hall. Thank you.
All right, and Ron, by the way, is here today. So if you do have any questions now, you can catch them right here, hopefully at the end of the session. All right, thanks for doing that, Ron. All right, so I'm going to shift gears now and talk about our RDS on an on-premises cloud real quickly. We're not going to go into this in detail because it's actually fairly similar as we continue to get consistency between our cloud platform for on-premises deployments and our Azure products or services, then this will continue to happen. Basically, when I talk about on-premises clouds, I'm talking about either a private cloud or one of our partner-hosted clouds. There's lots of large entities who want to build private clouds that have all of the same characteristics of a public cloud, even for their own departments and so forth, because of the things I talked about earlier, the fact that it makes it more cost-effective, makes it more flexible, and so forth to create that abstraction layer. On-premises cloud, essentially, you're going to have to build your own hardware, right? Because just like the guys at Azure did for us, now we've got to do it. And then we're going to install the Microsoft Cloud Platform components on top of that, Windows Server, System Center, and the Windows Azure Pack. Now, we've got two alternatives. We can build our own, or we can use the Cloud Platform system powered by Dell, where they've essentially integrated all this into a turnkey solution for us. What we did here, and by the way, I want to give a nod to our friends down at Dell, and in particular, Senthil Baladandayutham, who worked with me real closely on building up a demonstrational system and also some of the scale guidance measurements that you'll see later. So we built this system. We wanted to demonstrate some of these basic concepts like virtual networking and some of the storage technologies. We built it out of a pretty small system. and got essentially built an Azure-like environment with just 6 hosts. We had one for our management block of VMs, one for our perimeter. We had 2 hosts for our tenant workloads and 2 for our storage scale-out file server. We had 4 networks. We had one for the management traffic, one for the external connections coming in from the internet, one for our NVGRE traffic, and one for storage. And our storage was essentially a single JBOD with a bank of 12 standard HDDs and 4 high-speed SSDs. So now we can use tiering. If you're familiar with our storage spaces and some of those technologies, now we can get very high performance out of these types of deployments. Okay, when we've got it all put together, it looks something like this. You can see the management host in the upper left, and it's running our Active Directory, our SCVMM, and SQL. Now, I want to point out that Active Directory is not the same Active Directory that you're going to see in the tenants, right? This is the one that we're using to manage our fabric. So it's our fabric Active Directory. Okay, and this gets back to our isolation. We've got to keep strong isolation between our provider fabric and our tenants. And you can see at the bottom we've got our 2 scale-out file servers with our JBOD array. Our perimeter resources are there in yellow. We've got our HNV gateway component running there. Okay, and then the tenant is going to be 2 Hyper-V hosts where we're going to actually create our tenant deployments. And in fact, so the first thing we'll do is, just like in Azure, we're going to create our networking environment. So we created a virtual network. Okay, and then we spun up VMs on that virtual network. Active Directory, all of the same components that you saw earlier, right? We spin them up in VMs on that VNet, and off we go. So if we looked at that from sort of a block diagram point of view, lo and behold, it looks pretty darn similar to what we did in Azure, and that is not by accident. That's what I was saying about cloud consistency, right? So the 3 stripes at the bottom is where we've abstracted out the compute, network, and storage that we built, right? And that's using that cloud platform those cloud platform components. And then in this case, our management block is up in the upper left-hand corner. We've now got Windows Azure Pack and the System Center VMM console, and then on the upper right, we've got our perimeter resources, which in this case is just the HNV gateway, but we could add things like firewalls and load balancers and so forth into that section. And then in the middle, that's where we're building our actual RDS deployment for a given tenant, and it looks identical to what we did up in Azure. Create a VNet, we spin up a bunch of VMs, and so forth. And just like there, we're going to come in from the public internet through that firewall and those perimeter resources, authenticate it against AD, publish an RDP file, come in through the gateway, go to the broker, and get redirected to our RDSH server, just like we did in Azure. And as I said, over time, the exact same PowerShell that you can use up in Azure, you could use to build this and so forth. All right. So no RDS session would be complete without some sort of scale guidance, because this is the first question everybody asks. They say, oh, this is really cool. I want to start building these hosted desktops and apps. Looks easy, but how should I plan for my users? So I always start this with the same caveat. Your mileage may vary, will vary, in fact. So this is intended to be just guidance. Some measurements we made to kind of get you into the ballpark, but you got to go measure your apps with your users on your hardware to really make this accurate. Okay? Okay, so we used Login VSI, which is a third-party tool available to run workloads against our deployments. They have a light workload, they call it, that's canned in the Login VSI 4.0. They have a medium and a heavy. And then what we did is we built a test system that had a Dell PowerEdge Hyper-V host, and then we spun up 4 RDSH VMs on that environment. And what we did is we mapped virtual CPUs in the VMs to logical cores. So in other words, in the Dell PowerEdge, there were 20 cores, 40 logical because of hyperthreading. Okay, and we didn't want to overbook. In general, we don't recommend that. You don't want to overbook virtual CPUs for your RDSH servers. Okay, so we end up with 4 VMs, each with 10 vCPUs and 31 gig. And then we ran these different login VSI workloads against that configuration. Now, I don't have time to go through every single one of the measurements that we made, so I'm going to show you one as an example, and we'll summarize at the end. So the medium profile, what we did is we logged in users every 30 seconds until either the CPU, the physical CPU threshold in the host server got to 85%, or we got to 120 gigabyte memory threshold. And so in this case, we were CPU limited, so we hit that point first on the CPU, and then we ran steady state for a while. And you can see the memory followed suit, but did not get to the limit. So the result was we were able to get 200 medium users onto the system at that 85% CPU utilization, which translates to about 5 users per virtual CPU. Okay? So that's one of the key numbers that you'll want to remember as you're planning a system. Okay? And then, of course, we had 450 megabytes per user, so you want to plan for that. Networking and total IOPS were actually pretty small. This is pretty typical in an RDSH environment. Much higher IOPS when you go to those personal desktops we talked about earlier. Okay? Okay, so when you look at this, if you summarize the CPU and memory for these RDSH servers under different loads, basically we saw about 8 users per vCPU with a light workload, 5 for the medium and 4 for the heavy. So as an example, sizing, if I had a tenant that had 30, what I thought were going to be medium users, right, I'm going to need 6 vCPUs in my RDSH farm and 14 gigabytes of RAM, right? And that means I've got to do something like this. I'm going to create 30 users. I'm going to create VMs that have, like for example, I could create 3 VMs that each had 2 vCPUs, etc. But I got to make sure I've got that many vCPUs available to me, right, to handle that. All right, now let's talk about Azure. Because then we also get this question, well, I got a deployment on-prem and I'm thinking about moving it up into Azure. What should I plan for? Well, we ran these same measurements against some deployments up in Azure. Exact same tools, Login VSI 4.0, right? And this is what we saw. On-prem, you remember we saw, this is the medium workload. We saw 5 users per vCPU. In the case of where we tested in Azure, we saw 4. Now, it turns out, we were curious about why that was, and we traced it back. The test we ran in on-prem was using Intel E5 2600s, and it turns out we were running this test in central U.S., which uses AMD Opterons. And if you go look at the spec marks for those processors, it's about a 20% lower performance. So it exactly matched what we saw. So that explains it. Now, I will point out that other data centers inside of Azure use different processors. So again, your mileage may vary, right, depending on what data center you're using and what processors you're getting. But this at least gets you in the ballpark, as I said, right? So in this case, I've got those same 30 medium users. I want to move them into Azure. I'm now going to need 8 vCPUs and 14 gig, right? And so then, for example, I could have 1 A4, or I could have 4 A2s, right? Doesn't matter in that case. And people make the mistake thinking that it's better to have one big giant VM for my users. Well, remember I was talking about how cost is driven by VMs. So in fact, from a cost point of view, you want lots of little VMs because you want to be able to shut them down, right, and keep them turned off. Now there's a trade-off because if they get too small, then there's an overhead that starts to kick in. So generally I don't recommend going below A1s or possibly even A2s, depending on the size of your deployment and the workloads and so forth. All right, I'm going to summarize what we've talked about. I hope the key takeaways from this are that Microsoft has a number of cloud computing solutions. Obviously, our Microsoft Public Azure cloud. We have on-premises solutions, both our Microsoft Cloud Platform software and also our turnkey cloud platform system powered by Dell. And running RDS in these types of environments has a lot of benefits. And as I started this session, I was talking about, think about all the hardware I would have had to buy to build all of those demos that we just saw, and the time it would have taken me just putting the hardware together. And instead, I was able to just go up into Azure and boom, boom, boom. I had VMs and VNets and had this stuff up and running in a few, in hours. So it's amazing what cloud computing is really doing for the industry and what it will do in the future. Okay, so some web resources that are available to you. I showed you the reference architecture. We didn't talk about it, but we just published what we call a service provider reference architecture for desktop hosting. That is a document that walks you through actually how to build this on your own premises using that the Microsoft Cloud Platform. And we'll be adding to that with deployment guides and so forth. We talked about the automatic scaling script. And then last on the list here is our team blog, the RDS team blog. I highly recommend following that because we're always posting kind of the latest stuff, scripts that we're publishing, new features we're adding to either Azure Remote App or RDS and Server, and new documentation that we've published. So with that, I shall close. Thank you again for coming. And I will stay around for questions if you have any. In fact, we've got a little more time, so if you want to ask right now, that's fine. Or come up, either way. Yes?
Do you have two cloud services in your Azure deployment, one for the RD Web and one for the RD Gateway?
No, there's just one. He asked, do I have two cloud services for those deployments I just showed? No, there's only one cloud service that all the VMs are in.
So are they both publicly exposed to the internet on UCPS on TCP 443?
Yep. That's why you got to set up a load balance set. I know where you're going with this. Normally, if you have two VMs in the same cloud service, you can't give them an endpoint that has the same port number. The only way you can do that is if you put them in a load balance set.
Does that mean that the RD Web is listening on 443 and that the RD Gateway is listening on 443?
Nope, they're both listening on 443. It's Azure Load Balancer that takes care of it for us. What happens is when people come in, when you come in from your client, it says, oh, I'm trying to go to those VMs, one of them, and it uses its algorithms to figure out which one it's going to send them to, which is why you have to set that source IP affinity. So the question was, why did I set up a UDP port also for an endpoint? Well, it turns out that we use UDP and HTTP. So we use UDP for our multimedia type screen updates and stuff like that, and much better performance if you're going to, if the screen's changing very often, basically. So it's important to set that up if you want to get the best performance. Doesn't matter if you're just looking at static screens, but as soon as you start moving things around, watching videos or anything, you want to have UDP enabled.
So is the use of an RT gateway supported as trust?
The question was, is the use of an RDP gateway supported in a one-way trust? I think where you're going with that is, can you put your RD gateway in a different domain than the...
Right. So
the rest of the collection or the rest of the deployment.
Yeah, so here's my scenario. So we just started to test with Azure.
Yep.
And so because Azure is for us, because it's a semi-trusted space, we could leverage our on-prem access, right? So for experience that I had to create a brand new forest, right? So I have a brand new forest in Azure.
Yep.
And then all the VMs are joined with this brand new domain.
Yep.
So, however, when we want to RDP to these servers, we want to use our on-prem AD credentials. So what I did was I established a one-way trust, where basically this new forest trusts my on-prem.
I see.
It doesn't work. So I
Yeah.
an unauthorized error. So when I open up a thing with Microsoft, I'm getting different responses.
Ah.
It's been on one, and so I still.
Okay. Yeah, that's an interesting question. So he's got an interesting configuration here where he's trying to set a deployment up in Azure using one forest, and then he's got his on-prem with a different forest, and then he's trying to create one-way trust from the Azure domain back, but then use the on-prem credentials to get through. Yeah, I'd have to sit down with some guys back at the factory and think about that one, talk about that one. Yeah.
With Azure, but I'm thinking about it.
Mm-hmm.
And I heard there is this tool that can synchronize the account that you have on premises with the account you have in Azure.
Right.
Basically, password changes in Azure are going to be propagated on premises and the other way around.
Right.
Is that the solution?
That could be syncing, basically doing a sync between the two, where the counts are the.
No matter what, these are going to be two independent forests. There is no way to add Azure domain as another domain in the same forest that I'm using right now.
Right.
Is it? Or
Yeah, I don't know. I'd have to talk. Do you guys have some cards? I'd suggest. Yeah, I'll give you my card, and then this is something we'll have to take up with the AD team. I think sounds like.
so you're looking to do like an extension from what you have right now?
Yeah, so I'm trying to have it trust. Well, so it basically trusts my on-prem. Right? So whenever I try to use my
No, but this is maybe another question. For my environment is heavily based on RDS. This is what we do
Mm-hmm.
extensively. So I think for us, the starting point would be to extend our current environment to Azure,
Mm-hmm.
in smaller steps.
I see.
I will build an RDS stage in Azure. I'll see how it's working. I'll put some users out there, test it. You like it, you hate it, and
Sure.
work. Nobody would authorize me to start building this huge thing without testing it first. Right?
Yeah. So one of the things that both of you guys might be able to think about is creating. Have you thought about either a VNet connection, a VPN connection, or a express route connection from your VNet up in Azure back?
because the other thing that I did was I created another forest, right? That's on the same subnet. That's on the same subnet.
Yeah.
Right?